Good afternoon, Ajit sir. Hello. You are muted, sir.
Is it, is it fine, madam?
Yes, yes. Good afternoon, sir.
Good afternoon. Good afternoon.
We'll start our session sharply at 3 o'clock, sir.
3 o'clock. Okay, madam. Thank you. No. Satu tahun. Enggak? Oh, oh, oh. Ah, enggak? എൻ്റെ ലെക്ചർ ഏതായിരുന്നു ചിലപ്പോൾ അങ്ങ് 8 മണി വരെ പോയി എൻ്റെ ലെക്ചർ ഏതായിരുന്നു എൻ്റെ ലെക്ചർ
परत ती एसी of the ह्याला
Thank you, sir.
Hello, sir.
Yes, Neil.
Shall we start, sir?
Yes, Dr. Ajithkumar, मला वाटतं ते त्यांचा व्हिडिओ बंद आहे. Yes, he is there.
Yes, sir.
Welcome, Ajit sir. Welcome. Thank you. Yes, Neil, we can start now.
Yes, sir. Good afternoon and a very warm welcome to all the participants. Respected resource person Dr. Ajithkumar sir from Kerala Agriculture University, our organizing secretary Dr. R.P. Andre sir, joint organizing secretary Dr. J.D. Jadhav sir, in this 1 week online training program on advanced agrometeorological techniques for climate smart agriculture. Now, I would like to request our organizing secretary, Dr. R.P. Andale sir, to introduce and welcome our today's resource person, Dr. Ajithkumar sir.
Good afternoon, all of you. Good afternoon, all participants. I hope everybody has taken their good lunch. And now we can start our second session of this fourth day. Again, as per our daily routine, the responsibility of introducing our expert is with me, and I will introduce briefly our today's speaker, Dr. B. Ajithkumar, who is is holding the charge of head department of agriculture meteorology, Kerala Agriculture University at present, and he has completed his education, BSc Agri graduation from US Dharwad, post graduation from Kerala Agriculture University Velanikara, and PhD from Anand, Agriculture University Anand. Further, he has worked in various capacities, and now presently he is holding the charge of head department of agriculture meteorology, College of Agriculture Velanikara, and he has total more than 100 papers at his credit, out of which 25 papers are in internationally reputed journals of high impact factor, and he has also published several technical bulletins, popular articles, and many book chapters also. He is the life member of Association of Agrometallurgists and the Indian Society of Agrophysics. His expertise in the DSAT modeling and GIS and image processing will be definitely beneficial for us, for all the participants also. And he is also having, he is looking after the project Gramin Krushi Mosam Seva as a principal nodal officer and executive member of Association of Agrometallurgists. He is also the member of editorial board of Journal of Contemporary Research. and many other responsibilities he is holding. He has his vast experience. Considering his vast experience, we are fortunate enough to have him today with us, and let us listen to his talk. So I'll not waste much time and hand over the floor to Dr. Ajithkumar, sir, please.
Thank you, sir. Is it audible, sir?
Yes, sir.
Thank you very much for the nice introduction, sir. And the convener, SD Gauravanti, sir, co-convener, MG Shinde, sir, organizing secretary, sir, you gave thanks for the introduction. My own senior, Dr. Jadhav, sir, and other training coordinator, I'm very much thankful to invite me for this lecture. And it is a very good initiation. I think it's not an initiation, it's a series of lectures are going on, and it is very useful for the young agrometeorologists as well as we people also. We have learned many things from your lectures, sir. And which my capacity, I have given the topic on advanced instrumentation in agriculture meteorology. I'm going directly to my topic without any delay, sir. Okay. So advanced instrumentation, agrometeorology, when you are talking, whenever advanced instrumentation means wherever if instrument is not there, if a thermometer come to that area, it is become an advanced. Okay, sir. So first, let us see the observatory, the temple of a agrometeorologist or a person who is doing the climate research, a person who is doing the work on data and other thing. It is an observatory. We consider it as a temple because the data should be the correct and data should be well maintained. Data should be taken in the specified time and everything, sir. So first of all, we go from the observatory to the advanced sector. We will go, sir. So what is meant by an observatory? An observatory is a specially designed station or a place where the regular and simultaneous records of the weather data are made by physical measurements using various techniques. Here various sensors are used, various skills are used, and record instruments, etc. But it should be maintained with a standard methods recommended by IMD or World Meteorological Organization. So when we talk about the different types of observatories, in general observatories, we classify the observatories from class 1 to class 6, like special station. Class 2 is synoptic station. Class 3 is also synoptic station. Class 4 is climatological station. Class 5, rainfall station. Class 6, less or non-instrumentation station. Let us see what is meant by class 1 observatory and like that. In class 1 observatory, that is special station, we take orthographic recording and an eye recording. That is, all data elements are recorded at least thrice in a day. That is 5:30, 11:30, 2:30, that means 14:30, 20:30, and 2:30 ISTs. Whereas in synoptic stations, that class 2 synoptic station, eye reading observations are taken, almost all data recorded at least twice, that is 8:30 and 5:30 IST. In another synoptic station, eye reading data only will be taken, but the data will be taken only once, that is 8:30 IST. Whereas in the climatological station, eye reading without barometer, all data are recorded except pressure once a day. Whereas in class 5, eye reading only, rainfall is recorded daily. In class 6, that is, if there is no instruments, wind direction, cloud speed, visibility, etc., recorded daily. When we go to the agrometeorological observatory, we have auxiliary observatory, we have ordinary observatory, and we have a principal, that means class A observatory. In auxiliary observatory, the essential instruments are single Stevenson screen. It's not an instrument, it is a place where the thermometers are housed, and we should have a rain gauge. That is, non-recording rain gauge should be compulsory in that instrument. That is, temperature and rainfall instruments should be taken at auxiliary observatory. And optional instruments, if we have a space and other thing, we can go for wind vane anemometer as well as the dew gauge. In case of ordinary or class B observatory, the essential instruments are single Stevenson screen, that is temperature reading should be there, non-recording rain gauge should be there, that means rainfall instrument rain gauge measurement should be taken, and soil thermometers at a depth of 5, 10, 15, 20 and 30 centimeters should be there. And we should also have a class A pan evaporimeter to measure the evaporimeter. And wind vane and anemometer should also be there in the class B observatory. Optional instruments are, if there is space and if you have funds and everything, we can go for dew gauge, sunshine recorder, self-recording rain gauge, double Stevenson screen with thermograph and hygrograph. So when we go to the principal or class A observatory, all the instruments from class B observatory should be here, it should be there, and there should be self-recording rain gauge as well as thermograph and hygrograph. That means self-recording rainfall, temperature, humidity instruments should be installed in the class A observatory in the Agro-meteorological observatory. So in an Agromet observatory, this is the layout of an Agromet observatory. In an Agromet observatory, usually it should be practiced that based on the space, the north-south direction should be 55 meters and east-west direction should be 36 meters. So the sunshine recorder will go from the northern end. From the northern end, the instrument which are kept in the northern side, that is the instrument which is kept at a 10 feet height is kept in the northern side of the observatory. In the observatory, sunshine recorder will be kept in the northern side and it should be kept 5 meters from the fence or 5 meters from the end of the northern side. Thereafter, we should have a wind vane. Then comes the anemometer, which is kept from here. It will be around 14-meter distance from the end of the observatory. And in between this thing, it should be kept as 12 meters from eastern direction. It should be installed. Again, after leaving 12 meters, the other instrument should be kept like that here, 12, 12, 12, like 36 meters should be maintained here. So after this, we should go for the double Stevenson screen and single Stevenson screen. Thereafter, we'll have a self-recording rain gauge or an ordinary rain gauge. Then comes our soil thermometer should be placed here and open pan evaporimeter should be placed here, and then comes the dew gauge. So before going for the layout and everything, we should have a choice of the site. Choice means, first of all, if we go to a place, we should consider this aspect before starting an observatory in an area or a college or a university. When selecting a site for locating an Agromet observatory, all aspects of the locality should be considered. The results of the measurements of meteorological factors must be comparable from year to year and place to place. That means if an observatory has been placed in one place, it should not be changed every year. It should be permanent for a long time and it should be permanent only. Thus, the exposure of instruments should be as uniform as possible and homogeneity should be maintained. The observatory should be located at a site which is representative of the area. Representative of the area means it should have the same soil condition and everything we should be considered. And it should be in the middle of the field because we are going to do the agrometeorological research here. To ensure the homogeneity of the data, the site should not be shifted. As I already told that the site, if one selected, should not be shifted any other time. Therefore, the site has to be chosen prominently once for all. And there should not be any obstructions like tall trees or buildings from all sides. So it should be free from shades and other things. And I already told that the north-south direction, it will be 55 meters, and the east-west direction, it should be 36 meters. And the area should be well leveled, and there will be a barbed wire fencing, and also there should be of 1.5 meter, and there should be a gate, and all the fencing should be painted white. such a precautions we should given to our observatory place where the observatory is keeping. And another thing is that instruments in the observatory should be robust and durable. It should be simple for operation and accurate without calibration drift. These things also should be considered while the purchase of the instruments are taken. And another thing of the observatory and the observation is that the time of observation is very punctual. The punctuality of the observer is very important when you go for the agrometeorological observatory or any type of observatory. Punctuality is very much important. So here we used to take the reading at 7 hours LMT. That in case of Vellanikara, it is 7:25 a.m. So in that time, we take the observations of wind speed and direction, soil temperatures, Stevenson screen. With the help we'll take the temperature. That means first we'll take dry bulb, wet bulb, maximum and minimum, and morning hour we go for the setting of the maximum thermometer. What is meant by setting? When we go to the maximum thermometer, I'll just explain. And at the time of 8:30 hours IST, Indian Standard Time, we take the reading of, that is 8:30 a.m. We take the reading of rainfall as well as the evaporation. In case of 2 hours LMT, in our Vellanikara, it is 2:25 p.m. We take the reading of wind speed and direction, soil temperatures, Stevenson screen. That means temperatures. That is there also the order we maintain it as dry bulb temperature, wet bulb temperature, maximum and minimum temperature. And in the afternoon, we go for the setting up of the minimum thermometer. So morning we go for the setting up of maximum thermometer, whereas minimum thermometer setting is done during the afternoon time. And during again at 5:30 again we take the observation. Then we take the observations of wind speed and direction. Stevenson screen means temperatures. That again we follow the same thing: dry bulb, wet bulb, maximum, minimum, and setting up of the maximum thermometer is done during that time also. So during the dew deposition season, we take the dew gauge is installed there. And during sunshine cards are changed. Every day we have to change the sunshine cards. The sunshine cards are be changed before or after the before sunrise or after the sunset. We change the sunshine cards. And soil moisture measurements are taken as per the experimental required. If you want, we will take the soil moisture measurements also. So there we already covered the timing of the observation. So when we go for as an agrometeorologist, the observatory is is considered as a temple of an agrometeorologist, and the timing is very punctual. Punctuality in timing is very must. For calculation, I told that 7 hours, this local mean time corresponding to Indian Standard Time, we have to calculate. I told 7 hours LMT, whereas in case of Vellanikara, we take it as 225. How it is changing? Okay, the local mean time corresponding to Indian Standard Time varies from place to place depending upon the longitude of the place. So longitude is 82 degree 30 minutes. E passing through the Allahabad is called the Indian Standard Time. Here, IST and LMT are same. That means 7 hours LMT is equal to 7 hours IST at Allahabad station. So for getting IST of a corresponding LST of a place, the formula we used is LMT equal to IST minus 4 into L1 minus L2. That is LMT equal to IST minus 4 into, this is 82 degree 30 minutes is the longitude of Allahabad station minus longitude of our stations. In minutes we have to calculate. This is just an example for Hyderabad station. The Hyderabad station, the longitude is 78 degree 30 minutes east. That 78.5 east standard meridian. That means 82 degree 30 minutes we are considered 82.5. As per our formula, that is LMT equal to IST minus 4 to L1 minus L2. That is here IST minus 4 into 82.5 minus 78.5. That is IST minus 4. This will give 4. So IST minus 16 minutes. IST is 10 hours 30 minutes in case of Hyderabad. So what is the time IST? What is the local mean time we have to go for? And it is 10 hours 30 minutes. So here the IST minus 16 minutes you have to take. That is 10 hours 30 minutes minus 16 minutes. That is 10 hours 14 minutes is the time we should take for taking the observation. I hope all should understood that thing. And agrometeorology should know this aspect of converting LM, how to calculate the LMT from the IST. It is based on your place longitude. We have to calculate. Now we'll go for the radiation measuring instruments. The radiation measuring instrument, first of all, instead of radiation, we'll go sunshine hours. Sunshine hour we'll calculate using a bright sunshine hours in a day using a sunshine recorder. And pyranometer inside instrument, it measures the global, that is direct and diffused solar radiation. And pyrheliometer is an instrument which measures direct beam radiation at a normal incidence. Line content sensor, which is very much useful for an agrometeorology student or a person who do micrometeorological studies. That is, it measures the photosynthetic active radiation. Net radiometer is another instrument which measures difference between upward and downward total radiant energy directly. Tube solarimetry is an instrument to measure the incoming solar radiation. We'll just see what are those instruments to measure the solar radiation in detail. The sunshine recorder, I already told, it is known as Campbell-Stokes sunshine recorder. It is known as Campbell-Stokes sunshine recorder. Measures the bright sunshine hours in a day. So it is having a convex lens. You can see here. Here we can see that when we used to be young, we used to burn the cotton with a lens. The same principle is used, just a simple method only, but the same way. But the thing is that while installing the sunshine recorder, we have to consider the altitude, longitude, etc. Otherwise, the burning will not be taking place. So convex glass sphere mounted on the brass bowl with 3 sets of grooves are there. These 3 sets of grooves are there to install long curved, short curved, and straight curves inside the sunshine recorder. And this is the here we can see that the sunshine recorder in an observatory, we keep it in the northern hemisphere, northern side only. We are in the northern hemisphere, so in order to get the reading, we keep the sunshine recorder in the northern side of the observatory. It is kept at a height of 10 feet or 3 meter height. Why it is kept at a 3 meter height? Because these instruments are kept at a height of I told already it is 10 feet. So 10 feet is the shade should not fall on the other objects. That is why it is kept at a height of 10 feet or 3 meter height. As I already told, the principle behind the sunshine recorder is that it consists of a glass sphere towards which the sun rays are focused, and the glass sphere burns a trace in a card which is placed at its focal length. There are 3 types of cards are used here, and one I told you earlier, that is long curved, which is used during summer, and straight curved, which is used during equinoxes, and short curved, which is used during the winter period. These short curved cards are used between 15th October to 28th or 29th February. And afterwards, during long curved cards are mainly used during the summer season, that is 12th April to 2nd September. And straight curved are used during the equinoxes. Equinoxes are the time where the day and night times are equal. During that time, we use straight cards. Straight cards means 1st March to 11th April and 3rd September to 14th October. We are using the straight. This is the straight cards are using. Now I told about the pyranometer. I told it measures the global radiation. Global radiation includes both direct as well as the diffused solar radiation. These are some of the examples of pyranometer. And this pyrometer has originated from the Greek origin, that is, pyre means fire and ano means above sky condition. And pyrheliometer is an instrument to measure the direct beam radiation at the normal incidence. Okay, here the thermopile is used as a is used to convert heat into the electrical signal, and it is measured. The unit of measurement is watt per meter square. Now comes the line content sensor, which is already told. This is an instrument which is very much useful for an agrometeorologist, mainly during the our micrometeorological studies. It is a very good instrument. If you have this instrument with us, we can do a lot of research in the agriculture meteorology field. And it measures PAR, of course, we know it is photosynthetic active radiation. It ranges from 400 to 700 nanometer. And photosynthetic photon flux density is measured in micromole per meter square per second. Commonly, and PPF sensors are commonly called the quantum sensors. Quantum refers to the amount of energy carried by a photon. So line content sensors are often used to quantify the variable light in greenhouse and below crop canopies before they provide a spatial average of the information they will give. So in order to calculate the absorbed power, we need the readings by keeping the line content sensors at different levels of the field. Like on the top of the canopy, inverted we can keep the canopy. Inside the canopy we can keep. Like that we will get the information like PAR 0, that is incoming solar radiation. We will able to find out. IPAR means intercepted PAR. TPAR means transmitted PAR. R reflected PAR, that is reflected from the canopy plus soil, we can calculate. Reflected PAR means from the soil we can calculate, and absorbed PAR. This intercepted PAR is calculated from this equation. This intercepted PAR is incoming solar radiation minus the transmitted PAR, and reflected PAR is calculated from this reading, that is reflected PAR from canopy plus soil plus reflected PAR from the soil. So based on these readings, we can calculate how much amount of solar radiation has been absorbed in the crop area, crop canopy or crop structure. Okay, so absorbed PAR equal to intercepted PAR minus the reflected PAR. We will be able to find out how much energy has been captured inside the crop canopy. This net radiometer. This net radiometer measures the difference between upward and downward total radiant energy. Here also the unit of measurement is watt per meter square. This tube solarimeter is also a measure to measure the solar radiation only. It measures the combined effect of direct and diffuse solar radiation we will be able to find out, and measures solar radiation based on absorption of heat by black body. Is used mainly where distribution of solar radiation is not that uniform. That places we use the tube solarimeter, and here also the unit is watt per meter square. So in these units, we have already found that many sensors were used. That is, in temperature-related sensors are used. That is, thermocouples are used in many of the sensors. Thermocouples are junctions of dissimilar metals which generate an electromotive force in proportion to the temperature difference between the junctions. So copper and constantan is the most common metal pair for measurement of the temperature. So it gives a different, these different metals give different proportion of temperature. As a result of that, electromotive force will be generated, and that will be considered here. In case of thermistors are semiconductors with large negative temperature coefficients. That means the resistance decreases with rise in the temperature. So when there is a resistance is there, the temperature will be rising. This will be showing in a digital format or any other format for the users. The response is non-linear, and a fifth degree polynomial is generally found to fit between the thermistor resistance and the corresponding temperature. This is the net radiometer. As I already told that net radiometer records the net flux of in and out of radiation over the crop canopies. Ideally, it observes radiation of all wavelengths. So the sensing element of the net radiometer is a differential thermopile. What is a thermopile? You can find that here. We have an incoming energy is there. So we have a hot junction as well as a cold junction. Okay. So the principle of the thermoelectric effect is that generating a voltage when it is dissimilar metals are there, that is thermocouples, are exposed to a temperature difference, that is hot junction and cold junction is there. So the thermopiles can be constructed with a single thermocouple pair or a composed of a two thermocouple junction or a multiple thermocouple junction. So based on this thing, we will be able to calculate the variation in the temperature. This is the place where this is just an example. I will just show that this is direct solar radiation. Here we can this is all the solar radiation measurements are kept in one area. So this is the global solar radiation. Global solar radiation is always higher because it includes both direct as well as diffused solar radiation. Whereas direct solar radiation, when we compare it with diffused solar radiation, this global solar radiation with a shade ring, if a shade is kept here, it will act as a diffused solar radiation. Okay. So here we will get the diffused solar radiation, global solar radiation is that. That is here direct plus diffused is the here we can calculate the diffused. So if this instrument is not there, we can calculate the direct solar radiation with the help of global solar radiation and diffused solar radiation. Here we can see from the graph is that global solar radiation is very high because it's composed of both direct as well as diffused solar radiation. And if you consider the direct and diffused solar radiation, we can see that most of the months we will have the horizontal direct solar radiation highest, but whereas in June and July, we can say diffuse solar radiation is more. Albedometer is another instrument to find out the reflectivity, that is reflectivity of a place. So here we can use a pyranometer which can be inverted, and we will be able to find out the albedometer, which is also we can the unit is watt per meter square. Now we'll go to the wind measuring instruments. Wind, as we all know that horizontal movement of air is known as wind. Wind moving from a region of high pressure to a low pressure region. And up and down movement of air, we can consider it as a air current. So wind in the open air is having three-dimensional vector that has a direction of north, south, east, west in addition to a vertical components and magnitude. So wind blowing over the Earth's surface is always turbulent. It's a turbulent type and is characterized by random fluctuation of speed and directions are there. So the units used in wind is that it can be measured with the unit radiation. I told it will be measured in watt per meter square. Where this wind measurements can be made with the help of meter per second, kilometer per hour, miles per hour, feet per second, or knots can be used. So here measuring instruments are different type. One is wind measurement, and this can be measured with the observational type. Observational type, this is the most common is that the Beaufort scale. Beaufort scale, everyone knows that it scales from 0 to 12. And the observations are from the sea condition and land conditions are there. This is well depicted in our slide. And if it is calm means during the sea condition, sea is just like a mirror. There is no disturbances. In land condition, smoke is there. It will go vertically up without any disturbances. When it go to the 12th case, that is the higher phase, the wind speed is very high. Then we can see that there will be lot of disturbances in the sea, and the visibility will be affected. Visibility. And in the case of land condition, there will be large amount of devastation will be taking place. Like this, before scale is an term by if there is no instruments are with us. Based on the observation, we can find out whether the wind is calm or it is in the hurricane's condition. So wind vane is another. Wind vane is an instrument to measure the wind direction. And it is also, I told that it is kept in the northern side and it is kept at a height of 10 feet. That is 3 meter height will be there. The total direction which a wind vane is there. Here most of them we can see that there is a northern direction, main direction, south, east and west. In between that thing, we can see that there is NE, that is northeast direction, and here southeast direction, southwest direction, and northwest direction. Again, in between north and northeast direction, there will be another, that is NNE. That is, these two will be a degree of 22.5 degree. That means 22 point from 0, 22.5 is NNE. From 22.5, again 22.5, it will be 45. Like that, it goes to 360 degree. 60 degrees maintained. So the total directions, we can tell that it is 16 directions plus 2 is there. That is 2 in the sense during morning hours, mostly during the morning hours, we can see that when we go to an observatory, the first we have to see whether our anemometer is rotating or not. If it is rotating only, we can tell that the wind is coming, and we have to see our wind vane and tell that the wind is coming from a particular direction. If our anemometer is not rotating, we have to tell that our wind vane is calm. There is no direction at all. I hope you are understanding the meaning of a calm. And another thing is variable. Variable means if you go to the observatory, just go below the wind vane. If you see that the direction of the wind vane is changing from northeast, then again go to the northwest, again it comes to NNE. So we cannot able to find out the which direction the wind is coming. So we can tell that that direction is the variable wind. So there are 16 directions we are having, and if there is our anemometer is not rotating, there is no wind is coming, that means that particular time it is a calm condition. And if the anemometer is rotating in a very without an episodal manner, that means it is in the variable stage. So we have the wind vane here. It is the broad and bifurcated flank end of the wind vane offers the greatest resistance to the motion of the air goes to the leeward side. Leeward means from where the wind comes from. The pointer of the wind vane indicates the direction from which the wind is coming from. Okay, that is windward direction. A rigid cross arm is attached to this wind vane to indicate the wind direction of 16 subdirectional. That is, here we can see in a wind vane, we can see north, south, east, west. In between, we can see a direction. Actually, there are 16 directions are there, and it is kept at a height of 10 feet. There are different types by which vanes are being kept with the help of a potentiometer. There is a we can calculate the from where the wind comes from. Wind direction can be calculated with the help of vanes with a potentiometer. It consists of a transmitter and a receiver. Okay, there is a transmitter and also a receiver. The transmitter has three tabs, and the receiver consists of a rotor encompassing a permanent magnet and a stator with three 120-degree coil windings. And here 12-volt direct voltage is fed to the potentiometer through a sliding contactor and has a pair of contact points directly coupled to the wind direction axis. There is an axis is there. A current from the position of the sliding contactor is applied to the three coils of the stator in the receiver through the three taps of the potentiometer that generates a magnetic field to the stator. A pointer fastened to the rotor indicates that angle proportional to the sliding contactor position, namely the wind direction. So here it is rotating is that will be connected to this receiver point, transmitter to receiver point, and it is indicated here using a potentiometer. So with this also, this is also another method of finding the wind direction. There is another vane which is known as consists of two self-synchronous motors with the same structure. Within the same structure, that is transmitter and receiver is there. Here we have two motor system is there, and this whatever the changes taking place here will be indicated here in the receiver. We will be able to find out from which direction the wind is coming, and the wind speed also can be informed from this instrument. There is another instrument, that is vanes with optical pulse encoder. That optical pulse encoder consists of a disc featuring a special pattern of concentrically cut slits. This is the concentrically cut slits with light emitting diodes. Here the light emitting diodes are there, and a photo transistor, that is light receiving photo transistors are here. That is light emitting diodes and light receiving phototransistors are here. The pulse encoder used with this vane is designed to have a specific number of bits that meets the required angle resolution. Here we can, the 360 degree, 2 raised to 5 means 360 divided by 32, 11.25 is the measurement we have to take. And if a beam of light from the light transmitter, that is from light transmitter, passes through the circular disc and reaches the light receiver, if it completely is reaching the receiver, the signal we can consider it as a 1 is the output. If the beam is reflected by the disc, if it is reflecting back and does not reach the receiver, signal is considered as the 0. So the principle of the wind direction measurements with 5-bit encoder is that when a beam of light passes through the disc in the manner shows, a signal of 0, 1, 0, 1, 0 has been obtained. The 11th segment, that here we can see 0 to 7, and this is the 11th segment that it has passed. So how to calculate is that here we found that 360 divided by 2 raised to 5, that is 360 divided by 32, 11.25 we got. This 11th segment we have to consider calculate the angle between 11th into 11.25 and 12th into 11.2. That is, the wind has been traveling from 123 degree and 135 degree. That is, in between this, the wind is coming from these two directions. We will be able to find out. Wind speed measuring instrument. Up to now, we have calculated the wind direction, from where wind directions are coming with the help of different types of vanes are there. And here the wind speed measuring instruments are there. That is rotating anemometer. That's a very common instrument we are having in our observatory. It measures the wind speed in kilometer per hour and is kept at a height of 3 meters. Cup anemometer, of course, we know that, as I told earlier, when you go to the observatory, first we have to see whether the cup anemometer is rotating. Then only we should go and see whether our wind wave. Okay. If it is not rotating, that means there is no wind at that place and the speed is nil. That we have to write it as a cup. Here cup anemometer, we have a 3 semi-conical cups are set up in motion due to the pressure difference between convex and concave surfaces of the cups. The cyclometer, this is a cyclometer, is attached to the anemometer, which indicates the wind speed in kilometer per hour. The anemometer is installed in such a way that the cups are exactly at a height of, these cups are exactly at a height of 10 feet above the ground. Note down 2 readings at an interval of 3 minutes. Now we have to calculate what is the wind speed occurring now. For calculating that, this 3 minutes interval reading we have to calculate, and that difference divided by 20 will give the instantaneous what is the wind speed occurred that can be calculated. There's another instrument which is known as Dyne's anemograph. Dyne's anemograph measures wind pressure to ascertain instantaneous wind speed. Here also, based on the pressure, we are calculating the wind speed. Here we can see that there is an inlet hole. There is an inlet hole at the end of the pilot tube to measure the dynamic pressure and a row of small holes. You can see that small holes along the periphery of the tube at equal intervals to measure the static pressure. So we need to find out here the dynamic pressure as well as the static pressure. The pressure values at B and A, that is dynamic pressure and static pressure, caused by the wind are indicated through two pipes, that is C1 and C2 into the inside and outside of the uniquely shaped float in a column of water. The upward and downward movement of the float is recorded on a clock-driven drum, to represent the instantaneous wind speed. This is known as Dyne's anemograph, and it is very accurate one. And there is a hot air anemometer. It also measures the wind speed. The principle is that measures wind speed based on the theory that when hot metal wire is exposed to wind and then cooled, its electrical resistance changes. That is the principle. That is, when a hot metal wire is exposed to wind and then cooled, its electrical resistance changes. This change in the electrical resistance will measure the speed of the wind, and it indicates in the indicator. Another instrument, very accurate instrument, is known as sonic anemometer. In sonic anemometer, the principle is that ultrasonic waves of more than 20 kilohertz that are unaudible to humans propagated at a speed of about 340 meters per second in a wind-free condition. If there is no wind, this ultrasonic waves will propagate around this anywhere in the speed of 340 meters per second. If there is a wind, there will be a change in this 340 meters per second in the sonic anemometer condition. So this difference will be measured, and this will be converted into wind speed as well as the wind direction measurements. And this is very, very accurate instrument actually. Another instrument is SODAR, that is sound detecting and ranging. A SODAR device uses sound wave deviation to measure upper air wind speed. It is mainly used in the upper air, high altitude. What is the wind? We calculate with the help of a SODAR, that is sound detecting and ranging instruments are used. Now we have studied how to measure the wind speed as well as the wind direction. Based on this thing, we can draw a pictorial representation of wind speed and wind direction, that is known as wind rows. Wind rows are very much essential for planning and any type of architectural designs in our experimental fields. We need to study about the wind rows, in which direction, which month, which direction, with what speed the wind is coming, that we can be calculated. This is an experiment conducted by my students at our college, that only I am just showing here. Here the date is the 1st to 30th, that is in a particular month. What are the wind directions we know which has occurred, and this wind speed also we know during the particular days. Like that, every month we have to calculate. Now we have to calculate in the direction 9 how much frequency it has occurred. That we have to calculate. That is, if n has not occurred during that particular month, so it is kept at 0. Then percentage we have to calculate. Out of the total, how much percentage has been occurred, that we have to calculate. Based on this calculation, we may calculate the wind speed in each direction, and we will get a pictorial representation of that particular month in this direction, at what speed the wind comes usually. This is the wind rows presentation of different months. Different months is depicted here. Here we can find that during June, southwest monsoon is progressing. When it comes to October, November, northeast monsoon is progressing. This type of experiments we can do, and at what speed it is coming, that also we will be able to understand from this type of visual representation, that is wind rows. And it is very useful, and for the researchers to plan if any what we call the poly houses or anything to be installed in our area, we can give a direction to the other people, or we people in which direction should we plan the poly houses. Now we'll go to the temperature measuring instruments. So far we have seen the observatory. Now afterwards we have seen wind vane and radiation measurements. Now wind speed and wind, that is wind direction and wind speed we have calculated. Now we'll just see how the temperatures are measuring, temperature measuring instruments we can see. The temperature measuring instrument, we know that the temperature is known as the degree of hotness or coldness of a body, determined by, we can calculate with the help of a thermometer. That is the main instrument. We can calculate the hotness of the body. And here we have different units are there. Fahrenheit is there, Celsius is there, Kelvin is there, and many other units are also there. It mainly depends upon the boiling point of water as well as the freezing point of the water. In case of Fahrenheit, the water boils at a 212 degree Fahrenheit and water freezes at 32 degree Fahrenheit. In Celsius, we know that it boils at 100 degrees Celsius and 0 degree is the freezing point. In Kelvin, it is 273 and 373 for the freezing and boiling respectively. How to convert? Like if one unit is done, we can calculate the other unit. If we know the degree Celsius, how to calculate to degree Fahrenheit is this 9 by 5 into centigrade plus 32. And if you know the Fahrenheit, convert is degree Celsius is equal to 5 by 9 into F minus 32. So just convert 80 degree Fahrenheit to degree Celsius, which will come to 26.6, and minus 40 degrees Celsius equal to minus 40 degree Fahrenheit. This is the temperature where Fahrenheit and Celsius are equal. That is minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. So we will see what is meant by maximum and minimum temperature. Maximum temperature is temperature observed in a day is known as maximum temperature. Minimum temperature means the minimum temperature observed in a day. So I told from the beginning that there is a Stephenson screen. This Stephenson screen, these thermometers are kept inside the Stephenson screen and it is kept at a height of 4 feet. Why the Stephenson screen is kept at a height of 4 feet means because it at a height of 4 feet because when the shortwave radiation is received by the Earth's surface, it converts it into longwave radiation. So there are a lot of fluctuations were taking place below the surface of the soil. So this surface, if you go to the longwave radiation picture and the height, we can say that this radiation, the sensitive heat has become a constant at a height of 4 feet height. That is why everywhere the single Stephenson screen is kept at a height of 4 feet. When installing a single Stephenson screen in the northern hemisphere, the first thing we have to note is that the door of the Stephenson screen in northern hemisphere should be open towards the northern side. And when we go to the observatory, the first and the foremost thing we have to see that the first reading we should take it as dry bulb thermometer only. Why dry bulb thermometer means usually the students, when we ask the students, they will tell about the maximum and minimum thermometer. But first and the foremost thing we have to see is that the first reading we have to take is dry bulb thermometer because dry bulb means instantaneous temperature. Instantaneous temperature means at that time what is the temperature occurring. So by opening the door of the Stephenson screen, first dry bulb, then wet bulb, then maximum and minimum. Like that only we have to take the readings. And except for minimum thermometer, all other thermometers will having the liquid medium is mercury, and in the minimum it is alcohol is the liquid medium. And the length, breadth, and height of the single Stephenson screen is 56 centimeter, 31 centimeter, and 42 centimeter is the dimensions. And it should be painted white, and it should be it is always painted white. And I told about the setting up of maximum thermometer. the setting up of the maximum thermometer is done at the time of morning hours. Usually, we get the maximum temperature during afternoon. In between, we can tell 2 to 5. We can tell. 2 to 5, that's a big range I am telling based on different areas I am telling. In Kerala, in our place, we used to get the maximum reading by around 3:30. So there is a temperature lag is to take place. So in order to maintain that lag and other thing, in order if any thing happen, so the setting of the maximum thermometer we used to do in the morning hours only, during the early morning hours, 7:30 when we go and take the observation. At that time only we do the setting. Why this setting is taking place? Because here in maximum thermometer there is a constriction is there. Why this constriction means as the temperature increases, there will be an expansion of the mercury, and mercury rises and it reaches to the maximum temperature. Okay. And in the evening, in night hours, the temperature cools, so it will not come back because of this constriction. Okay, because of this constriction, this mercury will not come back. So this constriction, the morning hours, after taking the reading in the afternoon, in the morning hours, we have to give a full shake should be given. Then only this mercury will go back to the bulb again, and we have to, before setting, we have to see that the dry bulb thermometer and the maximum thermometer should be in the same reading should be there. This is the maximum thermometer, and the readings will be from -35 to +55 degree Celsius will be the range of the thermometer range. The minimum thermometer I told its range is -40 degrees Celsius to +50 degrees Celsius, and it is having an alcohol as a medium. And here we will have a meniscus is there, that is one index is there, and with this index, this is this index, and this index moves along with the head of the index we take is that the minimum temperature. Okay, if when this alcohol takes into this minimum temperature during the early morning hours, that is the minimum temperature occurs mainly before the sunshine only. Just before the sunshine only, the minimum temperature occurs. So during that time, it reaches up to here. Afterwards, when the temperature increases, the alcohol expands and it leaves this index here, and it goes to this area. Okay, and after taking the observation, the setting of the minimum thermometer is used to take during the afternoon hour by making a just make a slanting position. So this index will come and touch this meniscus and keep it. It works on the principle of surface tension. So I told about wet bulb and dry bulb. This wet bulb and dry bulb, when we go to the observatory, when you open the Stevenson, first we have to take the observation of dry bulb only and dry bulb only. Wet bulb and dry bulb are same only. If we get wetted with the water, then it is considered as a wet bulb thermometer. So based on this wet bulb and dry bulb thermometer, we will be able to calculate the relative humidity. Relative humidity with the help of dry bulb and wet bulb is calculated with the help of an agrometric table. And on 25th the dry bulb value we got it as 28.8 and wet bulb is 27.4 degrees Celsius. Okay. And based on this agrometric table, this is the page where we got this 89%. Here dry bulb reading is there. Here we can see the wet bulb reading. Here 28.8 and 27.4. You can see the relative humidity we got it as 89%. From the same side, here we have relative humidity. On the other side, we have the dew point temperature calculation is there. With the same dry bulb and same wet bulb reading, we can calculate the dew point temperature. That is, dew point temperature is 26.9 degrees Celsius. And with the help of this value, we can calculate the saturation vapor pressure. We have calculated here 26.9. Saturation vapor pressure is 26.9, that is, it comes around 26.6. That is the saturation vapor pressure. So at present we know what is the relative humidity, what is the saturation vapor pressure. So relative humidity by equation we can tell that actual vapor pressure divided by saturation vapor pressure into 100. That is the equation we use for calculating the relative humidity. So 89 we got as our relative humidity, and from this equation we calculate the actual vapor pressure, and actual vapor pressure we calculate it as 23.64. From saturation vapor pressure and as well as actual vapor pressure we can calculate the vapor pressure deficit. And when we go for the crop weather relationship, okay, we always, most of our students use relative humidity to take the crop weather relationship. For calculating the crop weather relationship, it will be vapor pressure deficit will be more useful rather than relative. And if you go for pest and disease calculation, relative humidity will be the more important. So crop weather relationship studies better to go for vapor pressure deficit because it is an indication of relative humidity only. Another very important instrument to calculate the relative humidity is the Berlin psychrometer. Berlin psychrometer can be taken to a crop canopy over inside a poly house. Everything here also the same dry bulb and wet bulb is the make out, and there is a handle. If we make it rotate the this dry bulb and wet bulb for a more time, the dry bulb reading and wet bulb reading we can calculate. Based on these two reading with the help of a psychrometric table, if in case of dry bulb and wet bulb from a Stevenson screen, which is hygrometric table, in Berlin psychrometer we can calculate with a psychrometric table, we can calculate the temperature as well as the humidity of a place. And this instrument, micrometeorological studies, this if other continuous instruments are not there, we will. It is a very useful instrument. Like just like in coconut, inside the coconut plantation, what is the temperature and humidity at different levels we can calculate with the help of a Berlin psychrometer. This is about the again back to the Stevenson spin. This is double Stevenson spin. As I told about the single Stevenson spin, here double Stevenson spin having a dimension of 112 into 31 into 42. 112 into 31 into 42. So here all the thermometers can also be installed. Other than that, thermograph and hygrograph and barograph etc. can also be kept inside this double Stevenson spin. What is meant by a thermograph? Thermograph, I told, there is an instrument. It is an instrument to record the temperature continuously. That is, it can measure the temperature continuously in 24 hours. What was the temperature in each hour? We will be able to calculate. The principle behind the thermograph is that it consists of a bimetallic strip made up of invar and brass, or different bimetal. Two different metals should be there. And these are the bimetals with invar and bar. Based on this, metal has a greater coefficient of linear expansion. This metal has a smaller coefficient of expansion. This difference in expansion is directed to a graph sheet, and this measures with this is connected with the ink, and these readings are measured in a graph sheet, and this will be useful to find out in a 24 hours period how much amount of temperature has been occurred. Like the same way, continuous recording of relative humidity can be measured, can be calculated with the help of a hygrograph. It consists of a bundle of clean and de-oiled human hair. The length of hair increases with increase in relative humidity in a logarithmic manner. The change in the length of the hair are fed to a lever mechanism. There is a lever mechanism which magnifies the motion, and this motion is recorded on a graph paper. At 24 hours reading, we can take the reading how much the humidity is varying in a particular day. We will be able to calculate. This is another instrument to calculate the relative humidity. The sensor is a human ear which expands and contracts depending upon the variation in the relative humidity. The needle connected to the sensor moves up if humidity is more and vice versa, used in controlled environments like greenhouse gases, mist chambers, and incubators. And this is also to measure the relative humidity only. This another instrument is leaf wetness recorder. It is used to measure the relative humidity. Here also human air is used. In most of the pathological works, we can use this leaf wetness recorder. And this is the another instruments like digital hygrometer or humidity probes are there. This is also used inside the chamber, and how much temperature as well as the humidity, this can be calculated with these instruments. Now we'll go to the soil thermometer. Soil thermometers in the observatory, we can see it is kept at different depths. That is, during the surface, 5 centimeter, 10 centimeter, 15 centimeter, and 20 centimeter, even 30 centimeters. Based on our requirement, we can kept at different depths. And there is earth thermometers are also available, which is kept at a depth of 100 centimeter, 150 centimeter. This soil thermometer should be facing toward the southern in the northern hemisphere. It should be facing toward the southern sides we have to keep. The soil thermometer should always face south in northern hemisphere and vice versa in the southern hemisphere. And the thing is that it is kept at a, they are supported. These distance should be 45 centimeter. And soil temperature sensors are also there. These are kept at a different depth based on the designs used in this. Thermistors are used, thermocouples are used, thermocouple wires are used, and averaging of different layers we can keep, and we can average it and we'll be able to find out the soil temperature sensors. Another temperature instrument is known as glass minimum thermometer. The alcohol, here also as per our minimum temperature, we used alcohol. Alcohol in glass thermometer with a small index, just like like in case of minimum thermometer is there. It also known as terrestrial radiation thermometer. The thermometer is exposed 1 inch above the ground surface on its supports over the glass plate. That is just 1 inch above the glass surface. We have to keep this instrument. The reading indicate the possibility of occurrence of ground frost will be there. When the instrument records 30 degree Fahrenheit or 0 degrees Celsius below, a ground frost is likely to occur. Like that, we can plan. The planning purpose of the glass minimum thermometer is very much useful. Now, another instrument we can use is that infrared thermometer. This is also very much useful for our micrometeorological studies, and also for the irrigation studies also it can be used. It is used to find out whether the plant is under stress condition or not. So it is fast and accurate, convenient, ideal for remote monitoring. The response time is about 1.5 seconds only. When you put the trigger, the rays will go and come back. Based on this thing, the temperature can be used. Even you know that during the COVID area, in all entrances, we are putting this infrared thermometer. But in agriculture purposes, the instrument should be very accurate. It should not be that that infrared thermometer which is kept in the entrance should be used in our agriculture purpose. Now we'll go to the rainfall measuring instruments. It is the precipitation of liquid that we know that it is measured in millimeter or centimeter. We have 3 types we can consider the measurement of rainfall. It consists of 3 types of rain gauges are there: ordinary or FRP. FRP means fiber reinforced plastic, and self-recording rain gauge is there. Then comes tipping bucket rain gauge. Here, ordinary rain gauge, which we all know as an agrometeorologist or any other observatory, if you go, we can see this type of rain gauges. It consists of a rim with upwards of 2 millimeters square area. It is having a base, it is having a collector, and a measuring jar of 20 mm capacity. Okay. The timing of observation I already told. During 8:30 hours and 2 hours we take the 8:30 hours IST and 14 hours LMT we have to take the readings. Okay. And here is a self-recording rain gauge. Self-recording, and another thing is here we will get the total amount of rainfall only. In a particular day, what is the total amount of rainfall, that only we will be able to identify. Whereas in case of self-recording rain gauge, it is a this is the prototype rain gauge. It consists of a ring. It is having a funnel, and a filter is there, from which there is a siphoning arrangement is there, and this amount of water enter through this funnel, and when it reaches here, this area, there is a float is there. Float increases up to this way, and this float is recorded in a chart, in a clock-driven drum is there, and the graph paper is there. As the water enter to this thing, this float will increase. It will increase up to this height, and after reaching up to this height, the water will ooze out through this siphon. One siphoning, in the sense that is 10 mm of water has been reached. Okay, in a graph, it is depicted in a graph. I will show you one graph. This is the graph. Okay, here we can see that as the siphoning, as the water enters through this thing, the graph paper will the graph will be increasing. Then it reaches up to 10 mm. The water will be oozes out through the siphoning channel, and then it suddenly come down. This one up and down means it is 10 mm of rainfall. This is the graph. Here we can see that there is an increase in the water, and it has reached to a plateau. Then it again go to this way, and here again it rises. That is 10 mm has reached here. Then it come down. Then again it has increased. Again it come down. And here we can see there was a huge in a period of 3 hours. 3 hours, we can see that there is a 40 mm of rainfall in this period. This is the importance of a self-recording rain gauge. How much amount of rainfall plus when the amount has been occurred, how much intensity of rainfall has occurred in a particular period. This is the graph of 17/8/2018, where we had a very bad flood-like situation. That is for 15, 16, 17 in Kerala during 2018 August. We had a flood. This flood has occurred because of this high intensity rainfall. These intensities can be able to find out with the help of a self-recording rain gauge. Now it is a tipping bucket rain gauge. Tipping bucket rain gauge, it consists of a pair of buckets, and when one bucket is filled with 0.25 mm of rainfall here, it tips, empties into a cylinder placed below the other bucket and comes in the position. So tip, why it has come tipping means one bucket fill, it come down, so at a tip has occurred. If one tip means 0.25, like that 10 tips have occurred means it is 2.5 mm of rainfall has occurred. Like that we can calculate. This tipping bucket is always connected with the automatic weather station. Now we'll go to the evaporation measurement in instruments. Evaporation, as you know, that it is the process where liquid water is converted into water vapor. And pan evaporation, we have two types of pan evaporation. In India, we use glass open pan evaporimeter, where in abroad and other places we have sunken Colorado pan evaporimeter is also used. And we can measure is 120.7, which is the diameter. There is steel well. The length of the height of the open pan evaporimeter is 25 centimeter. We have to add water up to 20 centimeter height, and it is kept in a wooden plank only. From the ground, it has to, because the airflow should be maintained here. If you keep directly down the wind, there will be an effect of radiation will take place. So there will be wooden. It should be placed above a wooden plank, and some air passage should be there in between this. This is again the pan evaporimeter reading only. So different cases are for measuring the pan evaporation. Different cases are there. In the first case, if there is no rainfall, and the water level in the pan is below the reference point. That I told you that there is a still well is there. We have to maintain the water level up to this still well, and based on the still well, water level in the pan is below the reference point. That still well there is pointer. The pointer the water level has to maintain, and if the water level has gone down from the pointer, the water is added to the pan. The water should be added to the pan. Then the pan evaporation equal to amount of water added. I hope you understood. And with the rainfall, which is if there is a rainfall, this is the condition where there is no rainfall. If there is a rainfall, which is less than evaporation, and the water level in the pan is below the reference point, then we have to add water. Then the total pan is equal to amount of rainfall plus amount of water added. That is the total evaporation. So in another case, if the rainfall is which is higher than the evaporation, and the water level in the pan is above the reference point, then water is removed from the pan. Okay, from the pan, the water level is high. We have to remove the water. The pan evaporation equal to amount of water rainfall minus the amount of removed water will give the pan evaporation rate. And if there is a very high rainfall, we will consider it as an overflow. We are not able to calculate the thing. This is the how we have to install our open pan evaporator in a place. This is another instrument to calculate is barometer. Barometer, as we know that it is used to calculate the pressure of an area. The principle is that the mercury column in the glass tube is supported by the pressure of the air. That is, this pressure will be there, and the mercury column will increase. This is the pressure exerted by that particular area, and it also measures in millibars and hectopascals. There is another a barograph as a hygrograph and thermograph. It also will be able to measure the continuous what is continuous in a day, how much pressure variation can be in a day. Diurnal this pressure variation can be measured with the help of a barograph. Hourly pressure changes can be calculated. And this also barograph I already told the sensor aneroid element expands or contracts to pressure changes in the atmosphere. The lever system is the amplify the movements, and pen marks records the chart. Units are millimeters and hectopascals. This is the dew gauge. I already told the dew deposition over water vapor condensed on a smooth surface. This is conversion of water vapor to liquid water, which is cooling process. And at a different height, the dew gauges are kept. What is from the soil, 5 centimeter, 25 centimeter, 50 centimeter, and 100 centimeter dew gauges are kept. And above these dew gauges, the water deposit will be calculated with the help of a photograph. Based on that, we tell it is exposed to special ion supported different air. Based on this, dew, how much amount of dew has been deposited in the dew gauge has been calculated. Now we have studied about the almost all the instrument at the observatory, like that temperature, wind and wind speed, rainfall, radiation, etc. Now we will just see how we will calculate the soil moisture. Soil moisture can be measured directly and as well as the indirect methods are there. Direct method is the best method for calculation in the soil moisture when we compare with indirect methods. The gravimetric method, everyone know that thing. That is the very best method to calculate the soil moisture. But if there is some problems in that, we have to go for the instrumentation. That instruments which commonly use the potentiometer, gypsum block, neutron moisture meter, and pressure plate apparatus. Neutron moisture meter, we know that there is a probe, scalar rate meter, fast neutrons are that radium or beryllium will be there, and there is an accessible tube is there. What is the procedure is that fast neutrons are released from the probe, which scatters into the soil. There are some fast neutrons are released to the soil. When it hit with the H water molecules, it gets slowed down, and these slow down molecules will come back to the sensor, An amount of slow neutrons which has reached the sensor is being indirectly shows that how much amount of water in the soil. This is a simple way of explaining a neutron flow. Okay, this is the principle used in the neutron flow. There's another instrument is potentiometer. Potentiometer is a sealed airtight water-filled tube with porous type tip on one end and a vacuum gauge on the other. This is the porous tip and the vacuum gauge will be the here. Potentiometer measures the soil water suction, which is usually expressed as a tension. The instrument must be installed properly so that the porous tip is in good. This porous tip should be in good contact with the soil. It is mainly used for the irrigation studies. And here we can see that when water is added into the porous tube, when this area dries up, the water will suck the water in out of the tension. If there is lot of water into that, it will take the water inside. This is the principle, and these tensions were calculated here. And based on these tensions, we can calculate how much amount of water present in the soil. This is gypsum block. Gypsum block is another method of calculating the soil moisture from the soil. This pressure plate apparatus, it is usually the most common method. It is also used to find the field capacity, permanent melting point, and moisture content at different pressure levels we can calculate. Gamma rays absorption method, this is also another method of calculating the soil moisture from the soil. Now I'm going to some other normalized different vegetation index part. NDVI. NDVI we can calculate. NDVI is mainly used to find out whether the crop is in stress condition or not. The principle behind the NDVI is that red light is absorbed by the chlorophyll in the plant and near infrared is reflected by the plant's leaf. Okay. If NDVI ranges from, we can see that the calculation is RNIR minus RN divided by RNIR plus RN. This is calculated with the help of a green seeker. Just I am going very fast actually. Some more slides I have to show. That's I'm going somewhat fast. This green seeker is an instrument to calculate the NDVI. It is handheld type is also there and mounted type is there. It is very much useful for our experiment in irrigation studies as well as in the stress detection studies. And this is a very important table with this NDVI values. This IMD, Ministry of Earth Science, is giving every time, every week they are giving NDVI values. Composite ending week number 22. That is the recent one, and week number 2. From here we can find out in every state they are giving. Actually, this is an example for Kerala. Every time we can agriculture is in a good state. Agriculture is in a moderate state, agriculture is in a moderate. Based on this, we can plan many things, whether to go for fertilization or what has happened to this area. Like that, we can calculate based on the NDVI maps. Another method of to calculate standard precipitation index. This is the drought index actually. So the SPI values comes between more than 2 to less than 2. It comes from extremely wet to extremely dry condition. If the value is that less than -2, that is extremely dry condition is coming. So this is also a Ministry of Earth Science or IMD's figure. Based on this, which area of India is coming under severely dry condition or severely wet condition, we will be able to find. This is also a very important output from our India Meteorological Department. Another thing I would like to show is the carbon dioxide. The carbon dioxide, we know that the greenhouse gases and I think the carbon dioxide is playing a great role, and how the carbon dioxide is affecting these plants also we know that. But increase in the increase in the CO2 is showing a lot of bad ill effects also. So from where this the CO2 measurements are taking, recently we have shown that it is 412 ppm is showing. This is measured at the Mauna Loa Observatory. It's a Mauna Loa Observatory, and this line is known as scaling curve because he is the person. Dr. Charles David Keeling is the scientist who has first started taking the observation of CO2 at Mauna Loa Observatory. Here we can see that it has already come up to a 412 ppm also. And this graph is seasonal variation. Here also we can say there is a seasonal variation. This depicted here. Here we can see during April and April to July there is an increase will be more in a year-wise variation, and whereas July it is decreased because during this area near to Mauna Loa and other area there is no crops. That is why the CO2 level is decreasing from July to October in this graph. Just for your information, I just want to show that thing. And we have seen that there are many carbon dioxide enrichment technology studies out there. These studies are calculated with the help of SPAR, OTC, phase, SACC, and CTGC experiment. That is carbon dioxide enrichment technology studies are there. First, let us see in very speed that's how the soil plant atmospheric research is working. This is spar chambers, means enclosed structures. The plants are grown under the controlled condition of temperature, humidity, and carbon dioxide. Here the principle is that this is the structure of the spar, and there is a glass chamber and a cooling coil is there, and there is a fan system and air handling unit is there. And here is a soil bank with plants. This plant is there. So we are pumping the carbon dioxide. We are pumping the carbon dioxide through this thing, and amount of carbon dioxide which are falling utilized by the plants, and the response of plants we will able to find out. And this will go to the cooling coil. There is an indicator is that how much amount of carbon dioxide has been released and how much has been taken back. That we will able to find out, and how the crop is performing to this difference in CO2. That we will able to find out. Is a very good chamber. If I think TNAU is having this type of chambers at their university, and open top chambers is another good chambers which will be able to find out the to study increase in temperature as well as increase in carbon dioxide, how the crops is going to behave. It is not only helping the crops behave, it also helps the studies are conducted that how the pest is behaving under high carbon dioxide, high temperature conditions. Here, this is the just going fast. This is the actually there is a gas chamber in OTC's OTC. This carbon dioxide cylinder is there. There is a regulator, there is a air compressor, and carbon dioxide supply will be there to all the three OTCs, and there will be perforated GI pipes, and CO2 will be entered through these GI pipes. And carbon dioxide analyzer will be there. That is how much amount of CO2 is releasing, and after using the OTC, how much is used by the CO2 analyzer. That means the same how much is released and how much is utilized. We can able to find out, and it is detected through a computer, and we can control the entire system. This is the how it is regulated. That is how CO2 is controlled and monitored inside the OTC is shown here. This is phase experiment. Here it is under controlled condition, whereas in OTC open top chamber, and under phase means free air CO2 enrichment technology. CO2 enriched air is released into the ambient environment without causing appreciable changes in other environmental variables. This is the phase experiment. If you get a chance, you can go to CRIDA or IARA, both the institute having these technologies with us. And this is a phase change sensor, CO2 supply system, CO2 monitoring system, and the data logger is there. Here, this is the plenum, and this is 2 meter length. It's a small phase string. We have phase string experiment is showing, and 8 meter length is there in this thing, the diameter. And the main important thing is that there's a CO2 supply system as well as centrifugal air blower is there. And Vindwin and anemometer is also present here, should be kept inside this phase. Why this anemometer kept is because wind, this CO2 through phase is very expensive. In order to reduce this thing, if the wind speed is between 1 meter to 5 meters square, we should only open only these gas lines only. So we can reduce the amount of carbon dioxide. So amount of carbon. If the wind speed is less than 1 meter square, we have to open the entire grid, so that then only it will reach to the entire crop. This is the pictorial representation of the phase system. Here we can say that when the carbon dioxide is inside, there will be increase in the temperature. There is a limitation for open top chamber as well as the phase technology. So we have taken the screen aided CO2 control, carbon dioxide control. Here, screen breaks the winds and create a turbulent mixing inside this thing. There will be mixing of air, and carbon dioxide will be easily mixed with these crops. Like that, also we can study the increased CO2 and temperature, how it is affecting the plants. We can calculate. This is a CO2 and temperature gradient chamber. This is also we can find at Frida, Hyderabad. Here also we can at different temperature and different CO2 we can maintain at different chambers, and how the crop is behaving to different temperatures and CO2 we can be studied. This is another instrument. Therefore, find a radio sound, and with the balloon we can track temperature, humidity, as well as the wind profile. We will be able to find. This is the photographs of our IMD Hyderabad area. Then automatic weather station. I'm not when we have seen our observatory. In almost all the observatory, Agromet observatory, we can also find automatic weather station. In automatic weather station, whatever the instruments what we told, it is present in a one single unit. This is working with a solar panel, and there is a temperature. And the main the beauty of this instrument is that every hourly reading we will be able to take from uh, this automatic weather station, and it can be stored in a data logger, which can be used for our research purpose. Another important thing what the agrometeorologists are using is the mobile application for the agrometeorological services. Here there's IMD as well as ICR, and under ICR, ACRB, or All India Coordinator Research Project on Agrometeorology, is doing a lot of work. And Meghdoot is an application. We know that it is completely used by our Gramina Krishi Mawsam Seva people, and also the Damu people. Damu is a new concept is coming, and many of the people have been absorbed there. Damu also the people are using. It is very much useful for the farmers. This is some of the screenshots of Meghdoot. And in Kerala, we have made an Agromet services for Kerala. This is also an app almost similar to Meghdoot, but it's almost in our language actually, and English is also there. Not only in this thing, we have from US Dharwad. I'm really happy that in this section our Venkatesh sir is also here in our session. He is the man behind this Havaman Krishi under ICR, under ACRP on agriculture meteorology. He initiated this work actually, Havaman Krishi. Later, ACRP on Anandpur people also made a app on Vatavaran. Vyavasaya Vatavaran, I don't know what exactly to pronounce, but these are really helpful to the farmers and the society. Like this, I'm just stopping now. Thank you very much. Thanks a lot for giving me a chance. Thank you, sir.
Thank you, sir. Sir, shall we start our question answer session?
Yeah, please.
Okay. One question
I went very fast because of that. I think the time limit and other things. Okay.
Okay, we will take some representative questions, sir, for just 5 to 10 minutes. First question is from Dr. Piyush Das. As coastal areas are having extreme weather conditions, so how far from the coast we can establish an agro observatory, and is there any issues to make this in the region?
No, Agromet observatory means it should be a representative of that particular area. Understood? And in coastal areas, we can say that IMDs are already having a representative observatories out there. If there is an agriculture related thing, we can go for, we can have an observatory there, because the wind and other thing will create a lot of problem there. The main issue is with the wind speed and the coastal area only mentioned, correct, madam? Hello.
Hello, sir.
The coastal area only mentioned, correct?
Yes, yes, sir.
In coastal area, of course, even with Thrissur, we can tell that it is around 45 kilometers away from the coastal area. When Pilicot station is there, it is only 20 kilometers away from the coastal area. We can establish a observatory, but in concern with the Indian Meteorological Department persons only, we can have a observatory there.
Thank you, sir. Next question is from Engineer Sachin More. Automatic weather station and digital instruments used for measurement of microclimate parameters are certified by IMD.
That depends, because we have many private people who are coming out with automatic weather stations actually. Many people are coming from private agencies. Based on our research options, we have to see whether to go to that this thing. And I don't know much about whether IMD is in other instruments like maximum thermometer, minimum thermometer. They are giving a certification and everything. AWS, I don't know much about that thing, but we purchase is directly from the private people only.
Okay, thank you so much, sir. Thank you for such a nice, informative, and interactive session. Now, I would like to invite um, one participants from this training program, Mr. Sachin Munde, who is a PhD.
Hello, Snell.
Yes, sir.
Before proposing the vote of thanks, we'll make some couple of announcements for the participants.
Okay, sir.
Huh?
Okay, sir.
One thing is that tomorrow's session, which was in the morning, 10 o'clock, instead of tomorrow 10 o'clock, tomorrow's morning session, we have to shift to tomorrow afternoon 2:30. So that is one thing. And the valedictory function, which was there scheduled tomorrow afternoon, will be held on Saturday, 4th July, 10 a.m. And before the valedictory function, we'll be having a short panel discussion of half an hour, say half an hour or 45 minutes. So the program will be like this. On 4th of July, we'll start at 9:15, the panel discussion. We'll have some panelists in the panel for the panel discussion. We'll invite the questions from the participants. Our coordinators have designed one Google form, which will be posted on the WhatsApp group. The participants will submit this, those participants who have the questions will submit this Google form, and the questions will be taken up in presence of the panelists. And even will keep the session interactive. Will allow the participants to interact with the panel members. So accordingly, from 9:15 to 10 Saturday morning, there will be panel discussion, and after 10 o'clock, there will be valedictory function, which will be presided by Vice Chancellor, Honorable Vice Chancellor, sir, and the chief guest will be Dr. Rathod, sir, and guest of honor will be Dr. Vyas Pandey. And the flyer for that will be floated by tomorrow morning. So accordingly, this is a slight change we have to make because of some unavailability of the guests. So on the 4th of morning, all the participants, I request all the participants to join us and be present. And the online certificates will be distributed during the valedictory function only. So I request all the participants to be present for the valedictory function, and note the tomorrow's change of lecture timing. Okay, sir. So you can invite Mr. Sachin Munde to propose the vote of thanks for today's topic, today's speaker.
Madam, can I audible?
Yes.
Today's lecture on advanced instrumentation in agrometeorology. This lecture delivered by B. Ajithkumar sir is a very nice and informative lecture to be delivered on based on the instrumentation and soil plant atmosphere based automatic weather station, some mobile application. Here is a very nice presentation and very informative lecture today. And thanks to organizing secretary of this training program, respected Dr. R.P. Andre sir, and joint organizing secretary, respected Dr. J.D. Jadhav sir, head department of agriculture meteorology, Pune. This is my opportunity to that kind to be vote of thanks for today's section. Thank you so much.
Thank you, Sachin.
Thanks to my senior Dr. S.G. Kannade ma'am. Thank you.
Thank you, Sachin. With the permission of today's speaker, Dr. Ajithkumar sir, organizing secretary Dr. R.P. Andre sir, and joint organizing secretary Dr. J.D. Jadhav sir, I declare that this session is over.
Thank you, Ajit sir.
Thank you, sir. Thanks for the
Thank you.
opportunity, sir.
Thank you.